Alright, so today you're going to use FET demonstration bending light to show index of refraction of different materials. To start the lab with, you can play around and get used to simulation, but this is what it needs to look like when you begin your lab. You will be collecting data. It says in your lab that you'll be collecting data about air and into gelatin. We will not be doing that today. We are actually going to be doing mystery B. So where it says gelatin on your lab, you're going to want to mark that out and write mystery B. Okay, and then you're going to be using the simulation to find that out that information. So if you'll look at this simulation real quick, I have set it at 10 degrees. Notice that's the first for incident ray. Incident ray A is 10 degrees for the incident angle. You see it coming in here. If you'll look here, it comes in here, and now it's going to enter the material. Part of the ray bounced back according to the law of reflection, but we want to talk about the ray that goes into the material. That's going to help us determine this N over here. What is the index of refraction of the mystery B? All right. So we set it at 10, and we see that down here it comes out at roughly 7, 8, somewhere around 8 degrees. So we need to fix that. So we're going to move this guy out of our way, and then we're going to go over this way, and we're going to write 8 degrees. Now we're going to bring this guy back up, a new guy back up, and we'll show you what that one will be in just a second. Alright, so now we have set up for the new set, which is 20 degrees. And if we look at 20 degrees, we'll zoom in now so we can kind of see. I put it at 20 degrees over here. It enters in, comes in here, the incident angle, and then enters the material here. Bends over to something like 14.5. So we'll go put that on our data chart. Okay, and then next we'll need to go ahead and bring up 30 degrees. Alright, if you look here, 30 degrees, I put it over here at 30, it's coming in at 30. We still have some reflected off. Notice that it still follows the law of reflection. This is our normal line here. We are going to go back over this way, and we should look that it's roughly 26. I'm sorry, that's not right. 21. So we got right about 21.5. So we're going to go add that to the data chart. Something we should note both times, we have started out with a bigger angle than what the angle of refraction is. This tells us that this light ray is slowing down because it is bending towards the normal. If it had been a bigger angle, then it would be speeding up. So we know that this index of refraction has got to be greater than air, and that's what we're going to solve for now. Alright, so if we look at our equations down here at the bottom, we need to try to solve for the index of refraction of these 3 degrees. I'm going to let you guys finish off the lab from 40 degrees to 70 degrees, but we want to solve from 10, 20, and 30. That's what we want to figure out. What is the angle of refraction and what is the index of refraction of mystery B? So we start off with this equation here. We rearrange it to solve for N2 because that will give us the index of refraction of the new material. So we divide both sides by sine of the second angle, and we put it here. And now we'll plug in our data that we know for the first one. Alright, so you see here that I put in 1 for the for N1. The index of refraction of air is 1. So if we want to put this in for air over here is equal to 1.0, that'll help you. So you'll always use that here in that first N1. Alright, so if we go ahead and plug that into our calculator, we'll get an answer. Make sure that your calculators are set to degrees whenever you enter this in. You may get a negative answer if you did it in radians. If you're using one of the calculators in my classroom, you will see RAD at the top, or DEG. DEG is where you want to be. If you're using a TI model, you hit mode and then go select degree. And then after I've done that, I come out to 1.25 is my index of refraction for A. So I come over here, I select my red, 1.25. All right. Now, I'll move on to B. All right, after doing the math for B, we see that it comes out to 1.37. Okay, and then we'll move on to C. All right, just a little note. This should have been 7.5. When I went back and looked at the data, it should have been 7.5. We should have gotten 1.33 instead of 1.25 for ray A, and then we see that ray C is 1.36. All right, go ahead and finish up the rest of the lab. You will average up all these guys together here, from here to here, divide by how many you have to get your average, and then begin to answer your questions. You may work with a partner. Have a good day.